Okay, so hopefully you guys can get yourself to a computer lab like the library to start playing around with Maple a little bit yourself. But I wanted to just give you an overview of what you should be getting from this since I'm not in class with you today. So I give you a little overview of how to actually like log into the computer, which I really hope you guys know how to do already. But and then to change some preferences so that everyone's looking at the same thing. Basically, I'm looking that you guys will get a little red Maple prompt. It'll be a little arrow like that. If you're used to seeing Maple in a different format and you don't want to change your settings to be this, consistent with the way I'm doing it, that's fine. I'm just trying to make it so that everyone is seeing the same thing. So some facts about Maple that you should read about here. Hopefully you did, about the difference between a colon and a semicolon, and how information is processed. And then the rest of this lab is really just playing around with some of Maple's tools. Right? So I wanted you to realize that Maple is, of course, obviously does things simple like what a calculator would do. So it adds and multiplies, and it knows order of operations. And so that's what you're supposed to have gotten from this exercise on number 1, so that you understand that this is multiplication and division. That's what these symbols for, right? So multiplication and division. When we go on to the next page, we see a few more things. Again, nothing rocket science here, but this would be the symbol for an exponent, right? So in fact, I tell you this all here. 2 cubed, if you want to write the square root of 16, you use the square root. Pi. So a lot of these things, and if these are not things that I expect you to memorize, but they're the kinds of things that if you forget, you can just Google. But I wanted to just have a little chance to play around with Maple. Okay, so it can evaluate functions. It can, but of course, it can do more than what a calculator does, right? So it can actually use variables and assign them to something. So, for example, if you want a to be stored as 17, you use this colon equals. So you'd say a is 17. You can say what b is, and then it remembers that. So if you add a plus b, it would output 20 because it would remember that. But more importantly than that, it also can create functions. So the same way we can assign the letter f to be the function that takes x, and this is supposed to look like an arrow. Like this, the notation is really like f takes x and it squares it, right? That's what it's trying to say. X is going from x and it outputs x squared. So if you then evaluate f of 3, it would tell you 9. Okay, so this is all great, and you could easily spend a lot of time talking about Maple and learning about its different uses. But the reason I'm talking about this now in class is because we just finished talking about finding limits. So again, I hope that all of this is what you've done already ahead of time, but if you're given some function f, I wanted us to just go over sort of the answers. F prime of x, we know, is the limit as delta x or h, whatever you want to say, goes to 0. Of f of x plus delta x minus f of x all over delta x. Now this is the notation I always use in class, but I think for the sake of Maple, it might actually be just as well for us to just adopt the h. So you can think of it as the same thing as this right here. Right? Either way you want to look at it, this is the definition. So now to enter the limit, instead of writing it this way, you have to figure out how to write it in Maple, and so we write the word limit, and then you have the parentheses f of x comma x equals c. That's just the notation they used for this. So if you enter this command right here into your into the screen from Maple, hopefully you realize that this is the same thing as the definition of the derivative evaluated at 1, right? Because so this is really saying it's the limit as it's telling me h is going to 0 of this thing right here, f of 1 plus h minus f of 1 all over h. So that is by definition f prime of 1. And likewise over here, this next one is finding f prime of 2. And finally for part E, we're finding the more general f prime of x. Now if you did do the step above, and you let f of x be defined as x squared here, all of these outputs in number 6, Maple would output it in terms of that f because it remembers what you called f. Okay, so I give you some more practice. G is now going to be defined as this new function, x squared plus 5. You're going to be finding this is again, the derivative, g prime of x. And what you should find is when that g prime of x is 2x, which is the same thing as what we got above when we took the derivative of f of x was x squared. So the point here that I'm supposed to be showing you here is that when f of x was x squared and g of x is x squared plus 5, they both had the same derivative. Okay, so using Maple, hopefully you were able to, and a process similar as above, so doing exactly what we just did. Hopefully you did this again ahead of time. I wanted you to find the derivative of each of these functions. So when we did this, what you should have found here is that this one you get x, this one you get 6x, this one you get negative 12x, this one you get 1/2 x, and this one you get negative 2x. So based on this chart, I was hoping that you would predict the derivative of the function 18x squared and then check it on Maple. So what I'm looking for you to do is see if you can come up with a connection between these functions and their derivatives. Okay, so we already remembered that the derivative of x squared was 2x, and then what you're supposed to notice is if I had a coefficient in front, like let's say the 3 here, so if I'm taking the derivative of 3 times x squared, notice that I got a result of 6x, right? That's what this says. The derivative of 3x squared is 6x. So notice that that is just 3, that's the coefficient, times the derivative of the x squared, so times the 2x is 6x. So the point you're supposed to be getting from this, and hopefully again you did this on your own, is that if you have some constant times the x squared, it really is just going to be that constant times 2x. So for part B here, if there's an 18 here, the derivative should be 18 times the 2x. In other words, you would get 36x. Okay. So again, for the sake of Maple, we are supposed to easily be able to find derivatives, not always having to use the definition of the derivative by hand, right? So I'm hoping you're catching on to the reason I would be doing Maple here. If we want to find a lot of derivatives quickly, we don't want to be using the definition of the derivative by hand. We can let the computer do that for us. Okay, so if the computer is doing this hard work for us, and by the way, all of these you should be able to do using the definition on your own. So it's not that you're not capable, it's just that this makes it more efficient. Okay, so if this is your function, then the derivative you should find would be 2x plus 3. This one you would get 2x plus 1. This one you get 2x minus 7. This one you get negative 12x minus 5. Here we get negative 12x period. And then here we get 6x plus 8. So I'm a little bit wondering if I meant to put an x here in my original problem, but whatever, it doesn't matter. Okay, so we're supposed to be noticing a connection here, right? So when we had our x squared, we know the derivative of x squared is 2x, so that's showing up. The derivative of x squared is 2x. So it must be that the derivative of 3x is 3, and the derivative of x is 1, etc. So if you were sort of looking at this and analyzing, I hope you were able to see enough of a pattern that we already know the derivative of 5x squared should be 5 times the 2x. And what I'm hopefully seeing you get from above is that the derivative of negative 8x would just be the negative 8. So in other words, the derivative is 10x minus 8. And again, I hope that you were able to confirm that using Maple. Okay, so we want to do a similar process again here. And so I'm going to leave this part as something that you do on your own, and I'm just going to summarize here that what you should have found in general is the derivative of something that looks like this. The a, which is a constant, stays out front, and then you'd be times the derivative of x squared is 2x. The b stays out front, and the derivative of x is just 1, and then the derivative of the plus c is 0. So altogether, we would get 2 times ax plus b. Okay, again, we want to use Maple to find some more patterns. So for 12, what you should have found would be 3x squared, 4x cubed. And again, I'm going to save this for you to fill in. In general, what you should have found is that the derivative of x to the k is k x to the k minus 1. And this is for k can be an integer, a rational number, a negative number, anything. So k is any constant. So in fact, this right here is what's frequently called the power rule. So to generalize, you pull down the exponent and you subtract 1 from that exponent. Okay, so that was the lab, and in class next time we will sort of summarize these rules, but I'm not going to want to spend a lot of time going over this MapleLab again. So if you have questions, please feel free to email me, and that way we can save time in class next time.